page 60. So we are given y equals the absolute value.
Is this R5?
Say that again. Yes, yes. We are continuing. Yeah, we are continuing. Yeah, we started R5 last time. Yeah. Yep. So on page 60. So, and then they're asking us to graph y equals x minus 3 in absolute value. Okay. So we graphed this function last time, and I'm hoping that you will remember it for a long time, which is the v function. And this is the absolute value of x. And when we graph x minus 3, you don't have to memorize anything. You don't have to memorize that it goes to the left or to the right. Just find the x-intercept. Where will the x-intercept be for this graph? And that's where the graph will move.
Three.
Very good. That's why it will move to the right. So which means you don't have to memorize that minus 3 moves to the right, positive 3 moves to the left. There is no need. Just find the x-intercept. When you set this equal to 0, this must be 3. Only 3 minus 3 is 0. Because we discussed that in order to find the x-intercept, we know that we have to make y equal 0. So when this is 0, only if x is 3. Okay, and back to our notes, our text. So again, if we want to graph any of this, so let's do that. I'm just going to make one up. So if we have y equals the square root of x, and we want y equals the square root of x plus 2, this is what I would do first. How do I find the domain of this function? What do I have to write?
X plus 2 greater than or equal to 0?
X plus 2 greater than or equal to 0. Excellent. Thank you very much. Yes, Manny, I saw that.
I was going to say that.
Okay, very good. I'm happy. Thank you. Greater than or equal to -2. So I know the domain is -2 to infinity. So nobody needs to tell me where to shift this graph. Where will you shift it?
To left.
Right, of course. Right? I don't have to memorize that. I have to remember the graph of the square root of x. And then this is very clear. It's a shift to the left of 2 units. No questions asked. So this is the square root of x plus 2. And this is the square root of x. But remember, you need to know the graphs of the absolute value of x, the square root of x, to make your life easier here. Because otherwise, there is no point in using transformations. So there is no need to graph these functions right now. We're going to graph them again. I mean, we can. I can show a step-by-step situation if you'd like. I just think that we are going to get to this in the next chapter in fine detail. Okay. Domain. I would like to look at the domain of any of these functions. Okay, let's take a look at 33, for example, on 60. So g of x equals x squared plus 7x plus 10 over x plus 2. So what is the domain of this function? What do I need to write? I'll stop sharing so I can see. Yes?
X plus 2 equals 0.
That was Manny? Okay.
Yes, for the domain, it will be parentheses.
So you said x plus 2 cannot equal 0.
Exactly. Cannot equal
okay,
0.
So then x cannot equal?
Minus 2.
Okay, very good. So now the domain, we are ready.
Then the domain will be, so from minus infinity to comma 2.
That's why we solve the equation, so we don't make that error.
Yes, -2, I'm sorry.
Good.
Union
Very good.
-2 to positive infinity.
Perfect. Just remember that these have to be parentheses. If somebody puts brackets, that's incorrect, because the bracket includes -2. Good. So I would like us to, we already graphed using x and y intercepts. We know how to do that already, unless you have any questions. I would like us to work on any, before we look at more domain, another domain, I would like us to review the exponential notations right here quickly. Okay. Any preference, or I will choose? Okay, so for example, in 51, we are asked to change this into a radical notation. Let's say 51. And 51 is b to -1/3. So can anyone remind us what is a to -n? What does a to -n equal to? Someone I haven't heard from? Yes, Kimmy?
Is that where you have 1 over a to n?
That's it. Awesome. So please remember that. And also remember that a raised to 0 is assuming that a does not equal 0. This is extremely important. Anyone remembers a raised to 0? How much?
1.
That's it. Awesome.
I
So,
had a quick question.
yes?
I'm sorry, what's the thing like the letter next to the -1/3 exponent?
B.
Oh, okay.
Sorry about
Thank
that.
you.
Sorry. Okay, so also the nth root of x to the mth power is the same with x. This is the power, this is always the denominator. M over n. So this is what we're asked to do. First of all, we're going to apply this rule, which gives us 1 over b to 1/3, and then we're going to apply this rule. And as you know already, I always run out of room. So this will be 1 over the cube root. The denominator is always the index, and the power is just the power of b. Yes, we normally rationalize the denominator. Anyone remembers what we rationalize it by?
B.
Mallory?
Wouldn't we multiply it by what is technically 1, but it would be cubed root of b to the 1 over cubed root b to the 1?
Careful. But if I have 1 here and 1 here, it's not going to be enough. I need to form a cube. So in order to form a cube, the 1 plus 1 will not give me a 3.
The square?
That's it.
Okay.
So this will be the cube root of b squared indeed, and this is b. Good. I don't want to forget, please make sure that you upload only one PDF file so I can make comments. Only one student did not upload last time one PDF file, but several, and I couldn't make comments on it. So please, one, if you don't know how to form or convert several pages into one PDF file, please stay after class so I can show you, please. And this is crucial for tests. Okay. So we just use radicals here. They're asking us to change back. So let's say 63. 1 divided by the square root of x squared plus 7. How will I change this into an exponential notation with no radical? Simone, what do you think? Simone, are you with us?
Where both sides?
I need a power here. So that this is this.
Will it be 2?
Power 2 will not bring it to the denominator. Don, would you like to give it a shot? Yes, Macaulay, go ahead.
-2.
But -2 will be 1 over x squared plus 7 to the second power. So -2 will not work.
Wait, what were you asking? I thought that's.
I want to change this into x squared plus 7 to a power, so that this piece is exactly this piece.
Is it 1?
Just go back and see what we did here.
I'm sorry, my internet crashed and I had to
That's
reconnect it.
okay. It happens. It happens to me too. Yes, Tyler, you want to try?
Would it be a -1/2?
Brilliant. Of course. So first of all, I bring it to the denominator as 1 over x squared plus 7 to 1/2. And 1/2, or the square root, is the same thing. So the square root of x is the same with x to 1/2. The cube root of x is the same with x to 1/3. Thank you so much. So please remember this, please. Okay, next, I like to look at one of these domains. Let's say, I don't know, 71, and then let's move on to demand and.
Excuse me.
Yes, I'm ready. Go ahead.
So when we have parentheses x squared plus 7 to the power of -1/2, we don't simplify it any further, like we don't distribute or anything. The
Okay.
power, so
Okay. So let's explain this. This is very important. Thank you so much for your question. The square root of a squared plus b squared does never equal the square root of a squared plus the square root of b squared. The square root of a squared b squared, yes, this is the square root of a squared plus the square root of b squared. But if we have a sum or a difference, we can never simplify.
oh wait, I get it now. My bad. I was
No worries.
having a brain fart. Thank you.
That's okay. Good question. Okay, where am I? I'm here. And the same thing with the square root, of course, over a ratio. So this is also correct. Assuming that these are real numbers, everything here is real. All real numbers, real numbers. Otherwise, no, the property does not apply. Oh, I'm sorry. A squared b times b squared is the square root of a squared times. Make sure that's very clear. Multiplied. That's why these two are okay. Assuming that everything here is real. In other words, I don't have the square root of -1 or the square root of -4. Okay, so let's look at a domain. So let's say like 75 or 71. And we have, in 71, we have f of x equals x to the third over x squared minus 5x plus 6. Can anyone help with a starting point? What do we need to do first here? Yes, Mallory, go ahead.
We need to factor the bottom so we can find out what x cannot be, what the domain cannot be.
Brilliant. Can anyone factor for us the denominator of x squared minus 5x plus 6?
I think it's x minus 1. I'm sorry, because is that a 5 in the middle?
Yes.
I just had to switch to my phone because my computer wasn't working. So it'd be x minus 1 and then x plus 6? No.
Minus
Yes.
2 and minus 3.
Oh. Oh,
So
well, that's
then
even better.
x cannot be
2 and 3.
2 and 3. So now the domain, anyone? Macaulay, go ahead. You are muted. Anyone else?
-3 to 2, close parentheses, the u, and then -2 through 3.
You mean 2 to 3?
Yeah.
Union?
And 3 to positive infinity.
Great job. Thank you. Very good. Okay. Good, so now let's talk about the equilibrium point. This is the last thing, the demand and supply. So, okay, let's start with 79. And we have the demand is 5 over Q, and the supply is Q over 5. So as you see, the supply, as price goes up, they want to supply more. For us, as price goes up, we are less and less willing to purchase, right? If the price goes to $10 million homes, less and less can afford, but they are willing to supply more and more. So right here at this point, everybody's happy. We are happy with the price, they're happy with the price, and they produce. So we want to determine the equilibrium point. So the demand is an increasing function, the supply is a decreasing function, and they meet here. And we want to find the equilibrium point. What do you think? What is the starting point here? How do I find the equilibrium point? What do I have to do first?